The next thing we're going to look at is closed intervals. Okay. Now, when you've got a curve, okay, if you don't stop that curve, it will stretch from negative infinity to positive infinity. Okay, now a closed interval means that you're going to look at a snapshot of the curve. So for example, if x was equal to minus 5 there and x was equal to 2, then that would be a closed interval that we would be looking at the curve within here, and the closed interval would be between minus 5 and 2. Now when you've got a curve and you close it off with these borders here, what you get is something that's called the closed interval. Now, what we're going to look to do is we're going to identify the max and min values of the curve in a closed interval. Okay, now there's an example of a curve that's closed in by a closed interval. Alright, now we can see that the maximum value of that curve, now the maximum value just means how high up it goes. The maximum value occurs at the turn point. Okay, so the maximum value occurs at the maximum turn point. Now here's a scenario in which we've got another closed interval, and where does the minimum value occur? The minimum value occurs at the minimum turn point. Because we see if we scan this curve, where's it highest? Well, it's highest here. Okay, so it's highest at its maximum turn point, and this curve, where's it lowest? It's lowest here at the minimum turn point. Okay. Now, is it always the case then that if you've got a closed interval, that the max value occurs at the max turn point and the min value occurs at the min turn point? And that's actually not necessarily true. Because let's have a look at this one. Now the max value of this curve, so how high up it goes, doesn't occur at the maximum turn point. This time it occurs at the end point. You can see that the end point is actually higher than the maximum turn point. So with this one, the highest point of the curve is the maximum turn point. For that one, the lowest point of the curve is the minimum turn point. But with this example, the maximum value of that curve isn't at the maximum turn point, it's actually at the end point of the curve. And then if we look at another one example, okay, where's the minimum value of that curve? Well, the minimum value of that curve's here. It's not at the minimum turn point. Now that means that the maximum value of a curve in a closed interval and the minimum value of a curve in a closed interval will either occur at the turn points or it will occur at the end points. So it will either occur at the stationary points or it will occur at the end points. Now, to establish what the max and min value is, what you need to do then is you need to check both the stationary points, and after you've done that, you need to check the endpoints. Now, typically what you'll get there is potentially, for example, 4 answers. And from those 4 answers, the maximum value will be the greatest number. The minimum value will be the least number. Now, that will either occur at the turning points or at the end points. Okay, so let's try an example and put this into action. Okay, so let's go example 1. Okay, now before we do actually, let's take this down. Okay, so in a closed interval, the max and min values occur either at the stationary points, SP for short, the stationary points, or the end points. Okay, let's get into that example 1. Okay, so we're going to find the max and min values of f of x equals (4x cubed minus x squared minus 4x plus 1 in the closed interval minus 2 is less than and equal to x, or rather minus 1 is less than or equal to x is less than or equal to 2. What that basically means is between minus 1 and 2. Okay, first thing, let's check the end points. Now what that means is we're looking at a snapshot of this curve, whatever it looks like. We're looking at a snapshot between x equals minus 1 and x equals 2. Okay, so the curve exists beyond that snapshot, but we're only interested in the snapshot between minus 1 and 2. Okay, now to find the maximum min value, that's how high up or down the thing goes, so that's a y coordinate. So what we do is we sub the x coordinates back into the original function because they generate y coordinates. So 4 lots of minus 1 cubed minus 1 squared minus 4 times minus 1 plus 1. Okay, minus 1 cubed is minus 1, minus 1 times 4 is minus 4. Minus 1 squared is 1, but there's a minus in front of it, it's up by minus 1, then minus 4 times minus 1 is plus 4, and now I've got plus 1, so it's going to be 4 taken by 1 is 3, 3 plus 4 is 7, 7 plus 1 is 8. Okay, so that's one of my values for the y coordinates, 8. Let's check the other endpoint. The other endpoint occurs when x equals 2. So it's f of 2 equals 4 lots of 2 cubed minus 2 squared minus 4 lots of 2 plus 1. So that's going to be 2 cubed is 8 times 4 is 32 minus 2 squared is 4 minus 4 times 2 is 8 plus 1. 2 take away 4 is 28, 28 take away 8 is 20, 20 plus 1 is 21. Okay, that's the second one. Now I've checked the endpoints. Now when I've checked the endpoints, I know that at the endpoints at minus 1, that curve will be going up to 8, and at 2, that curve will be going up to 21. Now I'm going to check the stationary points. I need to check both the endpoints and the stationary points. Okay, so to check stationary points, what I need to do is differentiate the thing and make it equal to 0. So that's going to be 12x squared minus 2x minus 4, and I'm going to set that equal to 0. And let's make that wee note, which is stationary points occur when f dashed x equals 0. Okay, so let's now take out our highest common factor, because there is one. I can take out a highest common factor of 2. So it's 2 brackets 6x squared minus x minus 2 equals 0. I'm then going to divide both sides by 2, and that will give me 6x squared minus x minus 2 is equal to 0. Okay, National 5 stuff now. 2 numbers that multiply give minus 12, add together to give minus 1 is minus 4 and 3. Drop 6x in there and 6x in there. I can now simplify both of these, factorise further. Okay, so I can take out a common factor of 2 from the first one, will bring it down to 3x minus 2. And a common factor of 3 actually for the second one. 3 into 6x goes 2x. 3 into 3 goes 1. Get 3x minus 2 is equal to 0. And 2x plus 1 is equal to 0. 3x equals 2 and x equals 2 over 3. And then I'll get x equals minus 1/2 from here. Okay, so next thing I'm going to do is get the y coordinates, so sub back into the original function. So f of 2/3, so back into the original function, 4 lots of 2/3 cubed minus 2/3 squared minus 4 lots of 2/3 plus 1. Okay, that'll give me minus 25 over 27. Now let's sub in minus 1/2. 4 lots of minus 1/2 all cubed, minus minus 1/2 all squared, minus 4 lots of minus 1/2 plus 1, enter in the calculator, and that'll give me 9/4. Okay, so let's just summarise the information that we've got. So we know that the minimum value that we get from the turning points is minus 25/27, and the maximum value from the turning points is 9/4. But how does that compare with the end points? Well, for the end points, I get 21 for one of them. There's actually a mistake in the one before. That minus 1 cubed is minus 1 times it before. That should be minus 4. So it's minus 4 plus 4 is 0. And then minus 1 plus 1 is 0. So that should be 0. Okay, so I've now got 4 answers. The 4 answers are as follows. So end point 1. F of x was equal to 0. End point 2. F of x was equal to 21. And then turning point 1, so we call maximum minimum turning points, they can be called turning points only. Turning point 1, and that was at 9/4. And then turning point 2 was at minus 25/27. Okay, so these are all y coordinates. So the maximum one is 21, so max value of the curve equals 21. So that actually occurred at one of the endpoints, and the min value actually occurred at one of the turning points. The min value was minus 25/27. Okay, let's try an example 2. Okay, we're going to find the max and min values in the closed interval. So the closed interval is between minus 2 and 1, so we're looking at this curve between x equals minus 2 and x equals 1. Now what is the curve? Okay, so the curve is f of x equals 2x cubed minus 3x squared minus 12x plus 5. Okay, let's check the end points first. Okay, so let's check the end point x equals minus 2. So into the original function, f of minus 2, 2 lots of minus 2 cubed, minus 3 lots of minus 2 squared, minus 12 lots of minus 2 plus 5. Okay, minus 2 cubed is minus 8 times 2 is minus 16. Minus 2 squared is 4 times 3 is minus 12. Minus 12 times minus 2 is plus 24, and then I've got plus 5. Okay, so minus 16 minus 12 is minus 28. Minus 28 plus 4 is minus 4. Minus 4 plus 5 is 1. Okay, let's check the other end point. X equals 1. F of 1, 2 lots of 1 cubed, minus 3 lots of 1 squared, minus 12 lots of 1 plus 5. 1 cubed is 1 times 2 is 2. 1 squared is 1 times 3 is 3. Minus in front. And minus 12 plus 5. 2 minus 3 is minus 1. Minus 1 minus 12 is minus 13. Minus 13 plus 5 is minus 8. Okay, so I've got end point 1. That's got a value of 1. Okay, end point 2, and that has got a value of minus 8. Okay, let's now investigate the stationary points. Okay, so for stationary points, I'm going to differentiate the function, make it equal to 0. Okay, so f dash x, that's going to be 6x squared minus 6x minus 12, and I'm going to set that equal to 0 and make my statement. Stationary points occur when f dashed x equals 0. Okay, so first row factorise and take out a common factor, 6 bracket x squared minus x minus 2 equals 0. I'm going to then divide both sides by 6. Okay, I'm going to come up here, x squared minus x minus 2 is equal to 0. Two numbers that multiply give minus 2, add together give minus 1. That's going to be x minus 2 bracket x plus 1. X minus 2 is equal to 0, or x plus 1 is equal to 0. So that's x equals 2, or x equals minus 1. Okay, so what I need to do now, I need to find the y coordinates, so I'm going to sub 2 and minus 1 into the original function. Okay, so the original function, just a reminder that that is f of x equals 2x cubed minus 3x squared minus 12x plus 5. Okay, so I'm exploring f of 2 lots of 2 cubed minus 3 lots of 2 squared minus 12 lots of 2 plus 5. 2 cubed is 8 times 2 is 16, 2 squared is 4 times 3 is 12, a minus in front, minus 24 plus 5. Okay, 16 minus 12 is 4, 4 minus 24 is minus 20, and minus 20 plus 5 is minus 15. Okay, let's investigate the y coordinate of the other stationary point, which occurs at minus 1. 2 lots of minus 1 cubed, minus 3 lots of minus 1 squared, minus 12 lots of minus 1 plus 5. Minus 1 cubed is minus 1 times that by 2 is minus 2, minus 1 squared is 1 times that by minus 3 is minus 3, minus 12 times minus 1 is plus 12, and then I've got plus 5. Okay, so minus 2 minus 3 is minus 5 plus 5 cancels out, and that will give me 12. Okay, so here's my 4 results. Endpoint 1, endpoint 2, turn point, and another turn point. Okay, what's the least value? Well, it's definitely minus 15. So the min value is minus 15. As we can see, the max value is equal to 12.